Hello, everyone. Welcome to the class of E-Plan and Electrical Control Technology. In previous lessons, when drawing the schematic diagrams, we focus on the functions of electrical systems. When some designs are at the preliminary stage, for example, when a company invites bids for a system and does not allow detailed information marking, it is completely sufficient to build an electrical system with symbols. But the design at the stage of production requires more details, such as part selection, definition of wire diameter and color, cable definition, and layout of mounting plates. At this time, drawings composed of symbols without detailed information on components cannot meet our design requirements. For example, when someone introduces himself as a good person, it only tells us that he is a person. If we want to know more about him, such information as his height, weight, work experience, and educational background becomes particularly important to us. Therefore, E-Plan's electrical design is divided into two levels according to the depth of information involved in the design: symbol-based design and part-based design. 1. Symbol-based design, also known as graphics-oriented design. The so-called graphics-oriented design is based on the traditional design method. It is to construct the logic of the engineering project with graphical symbols from the standard symbol library by inserting and invoking them from the first page to the last page of the project drawing. 2. Part-based design, also known as object-oriented design. The so-called part-based design means that the designer can select the correct electrical component model from the initial parts library provided by E-Plan software according to the requirements of electrical design and assign the part information to the symbols drawn in the electrical schematic diagram. Alternatively, the parts can be directly associated with symbols in the symbol library and then inserted into the schematic diagram. After understanding the difference between symbol-based design and part-based design, we can easily judge that when doing design at the preliminary stage, where the detailed information of the product cannot be displayed, the symbol-based design method can only be chosen. When designing at the production stage, we need to provide detailed product information, so a part-based design method must be selected. At this point, we should be clear that the electrical schematic diagrams drawn in the previous lessons are all symbol-based designs. In this lesson, we will focus on part-based design methods and ideas. This part is abstract and difficult to understand. To better understand it, let's first learn the following concepts. 1. Component. Symbols on a schematic diagram are called components, which are the individual units that make up an equipment. 2. Symbol. Simplified graphic of the component. It is a graphical representation of a component. The symbol can only exist in the E-Plan symbol library. 3. Parts. It is a collection of information about an electrical product, including manufacturer model, price, installation size, technical parameters, etc. 4. Parts library. It refers to E-Plan's database for storing parts information. E-Plan supports Access and SQL databases. 5. Equipment. It is composed of one or more components. The most typical examples are coils and contacts of contactors. Here, coils and contacts are components, and the contactor that they comprise is a piece of equipment. During drawing, the symbol in the symbol library is placed on the drawing to become a component. At this time, the component has certain electrical logic functions, but has no specific information, such as the electrical component model. After being associated with parts in the parts library and assigned with the corresponding product information, the component becomes a piece of equipment. After understanding the basic concepts, let's take a look at part-based design ideas. There are two main steps in part-based design. Step 1. Create parts. Step 2. Draw an electrical schematic diagram. Creating parts includes constructing a parts library, defining parts properties, etc. When drawing the schematic diagram, we can directly insert the equipment symbol with parts properties to the drawn page. Or we can first insert symbols using the symbol-based method, then associate the created parts with the symbols, and assign product information to the symbols drawn in the electrical schematic diagram. The above is the overall idea of part-based design. Do I make myself clear? In this lesson, we focus on the concept of part-based design. That is, drawing an electrical schematic diagram by inserting parts. A part is a symbol with product information. When the symbol is associated with a part, each component symbol we see on the drawing represents a specific piece of equipment. It helps generate a list of parts after the drawing is completed in the later stage. If it is necessary to draw a layout plan, a list of components can be generated for the part to facilitate the insertion of the mounting plate. However, these functions cannot be achieved by drawing only with symbols. In the next lesson, we will use the part-based design method to draw electrical schematic diagrams. Please stay tuned. Okay, that's all for today. See you next time.